but sec squared really is 1 over cos squared. So I'm going to say x plus 3 equals 1 over cos squared t. And so I get cos squared t equals 1 over x plus 3. And this was y equals 2 sine t plus 1. So say y minus 1 over 2 equals sine t. So can I find a link between cos squared t and sine t? Well, I know cos squared t plus sine squared t equals 1. And so say 1 over x plus 3 plus y minus 1 over 2 all squared equals 1. This might be a dodgy equation, to be fair, that you can't sketch. We're going to have a look in a second. So 1 over x plus 3 plus y minus 1 squared over 4 equals 1. And it's quite difficult to make y the subject here by the looks of it. So I'm guessing that is going to be tricky. And then maybe a table of values here would be the thing. Let's have a look. It might be really dodgy, right? Yeah. There's no way that we can sketch this. So we tried that. In an exam, obviously, they're not going to give you something that you can't sketch. In exams, I can't remember. Maybe once in 16 years, they've given a sub in values and sketch. Sketch a parametric by subbing in values. Okay, you can see from part E that is not a regular shape that we are used to. There is no way really that we are going to get to that using the information that we know at this stage. Right, any questions? So this approach did not work, and if that doesn't work, if we're not getting a curve that we can recognize, i.e. a polynomial or a reciprocal, we are going to switch to subbing in values. Right, okay, I do want to go back and just go over 5b. Any problems with the homework, by the way? I forgot to ask. So 5b, find the Cartesian equation of the curves given by that. So 5b, we are looking at x equals 3 cos t. Can't do anything with that really apart from to say x over 3 equals cos t. What can we do with the right hand side? We can use the addition rule. And so if I use the addition rule, if I take y over 2, the 2 over to the left hand side, we get cos t cos pi over 6 minus sine t sine pi over 6, which can be simplified. Cos pi over 6 is root 3 over 2, so we get root 3 over 2 cos t. Sine pi over 6 is a half, so minus a half sine t. and I've got y over 2 here. So I can say y over 2 equals root 3 over 2. Cos t is x over 3. So I've replaced cos t because cos t here was x over 3. So I can replace this. Now, sine t, we are going to have to use the other identity. 1 plus sine squared t equals cos squared t. Sorry, 1 minus sine squared t equals cos squared t. So what am I going to do? I'm going to say x over 3 squared equals cos squared t, which is 1 minus sine squared t. And so if I make sine t the subject from that, I get minus a half times by square root of 1 minus x over 3 squared. And now I can multiply the right hand side by 2. So we get root 3. If I multiply everything by 2, essentially the 2 at the denominator cancels out. And so we are left with root 3 times by x over 3 minus a half times by square root of 1 minus x over 3 all squared. Does that make sense? Are you happy with that? Okay, so I'm guessing the problem was with the sine t element, was it? Yeah. So whenever you want to get sine t from cos t or cos t from sine t, we want to be using the sine squared t plus cos squared t equals 1. And once we do that, that's fine. Y equals pi squared, so that's 3.14 squared. And it's the point, there's only one point, so there can't be 2 points. Now, if y has a value of 3.14 squared, then that's the same as saying roughly 9. So I'm guessing it must be, it must be a straight line that sort of looks like this, y equals pi squared. Which intersects the curve only once. So what can I do at this stage? Well, only the y coordinate is going to be pi squared. So I can say then, if y equals t minus pi over 6 squared, then pi squared equals t minus pi over 6 all squared. Does that make sense? Are we happy with that? And what we're actually going to do is find the t point at that coordinate. Right, you do that. Tell me what you get for the t value. And once you've got the t value, what are you going to do next to actually answer part A? Also let me know in the chat. So let's have a look. If we square root both sides, we get plus or minus pi equals t minus pi over 6. Okay, so you're realizing where errors are. So now t minus pi over 6 could either be positive pi, or t minus pi over 6 could be negative pi. So t equals pi plus pi over 6, or t equals minus pi plus pi over 6. So t is either 7 pi over 6, or t is, this is going to become minus 5 pi over 6. Which one of these is not the right t value? Which one of these is not a valid t value, please? Why is minus 5 pi over 6 not a valid t value? Because it is out of the range, yeah. We see the range is minus pi over 2 to 4 pi over 3, so this is out of range, so this is not valid. Out of range, so not valid. Now, we already know the point of the y coordinate must have been pi squared, because the height was y equals pi squared if we go back up to the diagram. We only need the x coordinate. How are we going to get the x coordinate, please? By substituting 7 pi over 6 into x. So x is going to equal cos 7 pi over 6 plus sine 7 pi over 6. Now cos of 7 pi over 6 is minus root 3 over 2. And sine 7 pi over 6 is also minus a half. So the coordinate becomes minus root 3 minus 1 over 2. I'm guessing. Okay, does that make sense? Can you please let me know in the chat if you are happy with that, please? This should have an x coordinate of 0. So we know that this has something 0, sorry, x coordinate of 0, not y. And B has some coordinates where x is 0 and y is unknown. So if in both cases x is 0, so what we can do is for the parametric equation, we can make cos t plus sine t equal to 0. That's right, isn't it? Now, if x equals 0, then I can now solve this equation. Say sine t equals minus cos t. I'm going to solve this equation, please. First year trig. First year trig. What will this turn into? That's good, tan. If I divide both sides by cos t, I get tan t equals minus 1. And what are the two t values? where tan is negative, well, cast diagram, we are going between minus 90 and 4 pi over 3 is 240, somewhere in here. So 0, 90, 180. I shouldn't have drawn that line. But our limit is only up to 240, somewhere in here. Tan is negative. So in which quadrants is tan negative? Tan is negative in S and in C. And if we do inverse tan of minus 1, we get 45 and 45. So T equals either minus 45 degrees or 135 degrees, which when we convert into radians, we get minus pi over 4 or 3 pi over 4. Does that make sense? Are you happy with those two T values? And they're both in the range. Once we have those T values, what are we going to do with them? What can we do with these T values once we have them? Well, if we go up here to the curve, the Y values are missing. So I now need to substitute these T values into the Y value. So here we are going to do Y equals minus pi over 4 minus pi over 6 squared. So let's just work that out. Minus shift pi over 4 minus so we get minus 5 pi over 12. So if I square that, we get 25 pi squared over 144 as one Y value. And the second one that we are going to do is 3 pi. So this was Y1. Second Y value is going to become 3 pi over 4 minus pi over 6 all squared. So here, oops. Seven pi over 12. If I square that, we get 49 pi squared over 144. So the coordinates of A are 0, 25 pi squared over 144. Coordinates of B are 0 and 49 pi squared over 144. Are you happy with that? Does that make sense? Please let me know in the chat. So if we think about this, we want to find where curves meet the x-axis. At the x-axis, your y equals 0. Okay, and I'll write that down. So if y equals 0, I'm going to say 0 equals 1 minus t and t plus 3. So my two t values are t equals 1 or t equals minus 3. Once I've got these, I can substitute them into x. So x equals t squared, so 1 squared, which obviously is 1, and x equals minus 3 squared, which is positive 9. If you're typing this in the calculator, please ensure that you've got the minus in brackets Because if we type in -3 squared, it doesn't give you, well, it does BIDMAS. It does 3 squared and then multiplies it by -1. Okay, so the two coordinates are 1, 0 and 9, 0. Okay, right, have a go at E next, please. So again, x-axis, y equals 0. So 0 equals t minus 9, 9 equals t, and so x is going to equal 2 times by 9 over 1 plus 9, which is 18 over 10, which is 1.8. So there's only one coordinate there. So that's fine, you've understood that. Right, okay, let's turn it up a notch. So looking at this, we've got x equals 4at squared and y equals a times by 2t minus 1. And we are told that the curve passes through 4, 0. So if it passes through 4, 0, then the x coordinate must have been 4, so 4 equals 4at squared, and the y coordinate must have been 0, so 0 equals a 2t minus 1. Now, I can work with either one, but I like working with equation number 1 because I'm not dividing by 0 and getting rid of something. Probably both still give me the same answer. It's quite easy from here to divide by a and get the t value, because a is a constant, but I'm going to check that in a bit anyway. So I'm going to do 4 over a equals 4t squared, and so I get t squared equals 1 over a, and so here, if I substitute that back into the second one, get a times by 2 times by root 1 over a minus 1. So either a equals 0 or 2 root 1 over a minus 1 equals 0. And so 2 root 1 over a equals 1. Root 1 over a equals 1 over 2. If I square both sides, I get 1 over a equals 1 over 4. I'm getting a equals 4. Let's check it. B also. Yeah, I'm getting a equals 4. Can you check where you've gone wrong? I'm going to do this second way as well. Well, let's say I've got 4 equals 4at squared and 0 equals a 2t plus 1, sorry, 2t minus 1. Because a is a constant, it's like saying 3x squared equals 0. We could divide by the constant and get x squared equals 0. So at this stage, I can do 0 over a, and I get 2t minus 1. So 0 equals 2t minus 1, and t is equal to a half. If t is equal to a half, I can now substitute that in here. So we get 4 equals 4 times by a times by a half squared. So I get 1 equals a times by a quarter, and a therefore is equal to 4. So we have got this answer both ways, which is same as that, right? Okay, so you forgot to expand, so just be careful with that. Oops, sorry, right, here's the next one. Have a go at this and let me know what you get for this, please. Talk me through what you're doing so I can check. How are you getting on with it? We are given a pair of parametric equations. 3t plus 2 is x, and y is 1 minus t. Okay, so x and y. And then we are told that x plus y equals 2. Well, we know what x is. We can just substitute that straight into x. 3t plus 2 plus that straight into y. 1 minus t equals 2. And that will give us our t values straight away. So we get 2t plus 3 equals 2. 2t equals minus 1, t equals minus a half. And so once we get that, we can now substitute this back into x and y to get our pair of coordinates. So x is going to become 3 times by minus a half plus 2, which is a half, and y equals 1 minus minus a half, which is 3 over 2. And so the coordinates of the linear equation with the parametric equation are half and 3 over 2. Are you happy with that? Does that make sense? Right, okay.